Hello and welcome to Boxer's Shorts. I'm Adam Boxer and I'm a science teacher trying to help you understand more of GCSE science. In these short videos I will try and take difficult concepts from GCSE science, break them down, help you understand them, and then do some practice questions on those concepts. In terms of some general tips for using these videos, definitely do not have your phone on or anywhere around you. It's a distraction and it means you won't be able to concentrate properly. The same applies for other tabs on your computer, so don't have your social media tabs open on your computer or laptop, it will just distract you. I'm going to ask you to do some questions. If you don't actually do them, you won't actually learn anything, so make sure when I do ask you to do those questions, you do them. And finally, let me know in the comments if there is a topic that you want me to cover. Thanks for listening, and remember you can subscribe and just let me know if there's something you want me to do for you. Hi, today we're going to be doing kinetic energy, and this is our most complicated equation yet. Kinetic energy deals with the energy of moving objects. Okay, so let's say I've got a ball, and the ball is moving. So as we've done before, what are the things that its kinetic energy depends on? So one thing that's pretty obvious that it should depend on is its speed. Now things are a bit more complicated than that, and again, like I said to you in the last video, you're going to be learning more about this later on. Unfortunately, the physics course is a bit kind of tangled together, but what we're going to do is we're going to call our speed V, because that's going to stand for velocity. So if velocity goes up, i.e. it goes faster, kinetic energy should also go up. Now the one that you might not guess is M for mass. In fact, the bigger the mass of something, the more kinetic energy it has as it moves. Now in fact, actually, when you think about it, that kind of makes sense. If you get hit by something that's moving and has got a really big mass, like a bus, it's going to throw you really, really far. It's going to hurt you a lot, even if it's not moving that quickly. So for example, if a bus is moving quite slowly down the road and I get hit by that bus, I'm going to be hurt more than if, for example, someone throws a tennis ball at me. So they threw the tennis ball at me quite fast, so it's moving faster than the bus, but it doesn't hurt me as much because it doesn't transfer as much energy to me. The bus has got so much energy and it transfers all of it to me. When it's, well, not even all of it, it transfers a lot of that to me when it hits me, that amount of energy causes me a serious amount of harm. So it depends on the velocity and the mass. Unfortunately, it's a bit complicated because you'd think then it would just be kinetic energy equals the mass times the velocity, but it's not. We say E, okay, put a little K over there, equals half times the mass times the velocity squared. Now there's two things here that don't really make much sense at the moment. Why is it times by half? Why is the V squared? It is what it is. There are reasons, very good reasons for that, that depend in part on mathematics that goes a bit beyond what we're doing in these videos. There are other ways to explain it without using those maths, but I'm not going to do those now because you don't need to know it and it's a bit complicated. For the minute, because this is just a short video, all you need to know is that kinetic energy is half the mass times the velocity squared. In the description to this video, I'll put a link to a very good article that explains where this half comes from. Now, in terms of our words, so we'd have kinetic energy or kinetic energy store equals a half. That doesn't need to be changed into anything. Times the mass times the velocity squared. In units, joules, half times kg for mass, and then the velocity squared, the units are meters per second, and I'll put all that in brackets and square it. Meters per second. What does this mean? It means how many meters it goes every second. So if something has 10 meters per second, it means every second it goes 10 meters. So 100 meters per second, it means every second it goes 100 meters. Okay, so this is kind of Usain Bolt fast, 10 meters per second, Usain Bolt fast. This is 10 times as fast as Usain Bolt, so a car going pretty quick. Okay, so 100 meters every second, car going really fast actually. All right, let's do a couple of examples. Let's say I've got a ball which has a mass of 15 kilograms and it's moving at a velocity of 28 meters per second. D, E, S, C, U every time. Data. I've got my mass equals 15 kilograms. I've got my velocity equals 28 meters per second. My equation. EK equals half times the mass times the velocity squared. Let's substitute. EK equals half times 15 times velocity squared, which is 28 squared. And now I need to calculate. Now it's really important that when you do that squared, you're only applying it to the 28 squared. So I'm going to do this in 2 steps. So I'm going to say EK equals a half times 15 times, and then I'm going to get my calculator out. And I'm going to say 28 times 28, or use the squared button to get 28 squared, and I'll get 784. EK therefore is half times 15 times that, so 0.5 times 15 times 784 gives me 5880 joules, and that there is done. Please, please, please make sure when you do that squared, you don't do half times 15 times 28 and then square the whole lot. The squared only applies to the 28. It doesn't apply to anything else there. Alright. Let's say then I've got a ball whose mass is 4.3 kilograms. I don't know how fast it's going, but I know in terms of its energy it's got 3,760 joules. D, E, S, C, U. I'm going to leave quite a big space over there for the C so I can see what's coming. Data. EK equals 3760 joules. M equals 4.3 kilograms. V, don't know. Something I should have made clear before, by the way, that V is a little v, it's lowercase. Substitute 3760 equals a half times by 4.3 times by V squared. Alright, now this looks a bit more complicated than we've done before. Now the first thing is always to just do what's easy when you look at it. So what's easy here? Half times 4.3. That's pretty easy. So I'll do 3760 equals a half times 43, which I'll do in my calculator. Sorry, 4.3, not 43, which gives me 2.15 times by V squared. Now this is similar if you had in maths, say, if you had, say, 100 equals 4 times x squared. That's what this is. In order to solve this, what we'd do is we'd divide both sides by 4, and we get 25 equals x squared. We'd then square root both sides, and we get 5 equals x. We're going to do the same thing here. First we're going to do the divide, 2.15 divided by 2.15. So 3760 divided by 2.15, that gives me 1748.84 equals V squared. And then you square root both sides. So I get V equals square root of my answer, which is 41.82, and my units 41.82 2 meters per second. By the way, you should notice that I'm really good at these. I'm really good at solving these, and I was really careful to break down everything into one step at a time. I guarantee you, if you try and do more than one step in one jump and you're like, oh, I got fancy fingers with my calculator, don't do that. Okay? Just be really careful, really deliberate, really slow, and then you won't get it wrong. Let's do one more example like this before you do some free practice, because I just want to make sure that you know how to do this and aren't screwing it up before you start doing practice, because what I don't want you to do is to make loads of mistakes. So let's say I've got a ball as before, and this ball is 800 grams. Note, 800 grams. I don't know how fast it's going, but I do know that its energy is 347 joules. What I'd like you to do is pause the video and try and work out what is V, and then when you're ready, play it again and I will run through the steps. Okay, so don't watch this if you've not done the question. If you've not done it already, you're wasting your time now. D E S C U, data EK 3475, and mass equals 800 grams. Now immediately I need to change that to 0.8 kilogram. Equation EK equals half times mass times velocity squared. Sorry. Okay, time to start calculating. Half times 0.8 is 0.4 times v squared. Oh, sorry, I should have written in my EK both of those points. Okay, so I'll divide both sides now by 0.4. So I get 8687.5 equals v squared, and then square root both sides. 93.21, my unit 93.21 meters per second. If you got that, well done. You can now move on to questions. If you didn't get that, I suggest you go back to your workings, see where you went wrong, and then cross the whole lot out and try and do it again from memory. Questions on kinetic energy. As ever, have a go, pause the video, have a go at the questions, and then when you're ready, press play again. Alright, so your answers to those. You've got a train waiting at a station with zero energy in its kinetic energy store. That way, because its velocity is zero. So if kinetic energy is half the mass times the velocity squared, if you put 0 into there, it doesn't matter what else is in there, kinetic energy is going to be 0. Why does the lorry have more K? Oh, excuse me. Because the mass is going to be greater. There's your calculation for a ball, which is just, that's a straight calculation. You then have to do a rearrangement to get the velocity. And remember, you'd need to do a square root at the end of that to get the V. And number 5, you've got to toss pancake. And again, to get the V, you'd have to do a square root. You've got an alien spacecraft. And here you'd have to do a rearrangement to get a mass that large. What might have thrown you a bit is that there's a energy conversion there, so you've got 786,500 kilojoules, so you'd have to multiply that by 1,000 first in order to get the energy in joules. And you've got your bit traveling very, very fast indeed, and again there's another conversion. Then you need to square root your final answer. So there are all your questions. Well done if you got all those correct. And a reminder to subscribe to the channel. Let me know if you have any feedback or anything you want me to cover, and that these questions are adapted from Rosalind Walker's booklets, and there's a link in the description. And yes, thank you very much for listening.